All right, guys, we are almost done with factoring, if you can believe it or not. However, we have one more method to talk about today. It's factoring by grouping, but I thought it might be helpful to review everything we've done first, how we solve different ways, depending on how many terms we have, before we get into our last method. So let's start just by going all over different methods and things we've seen so far. So if we start with one term, like for example, x. Good news here is there's nothing to factor, there's nothing to do. We are done. Okay, let's move on to two terms. If we have two terms, okay, then it must be either dots, SOTC, or DOTC. Okay, difference of two squares, sum of two cubes, or difference of two cubes. Or it's prime, prime meaning we can't factor it. So let's look at 3x squared minus 27, for example. Remember, the first thing we always do when we factor is we want to see if there's a GCF we can take out. And here there is. I can factor out a 3, and I'm left with x squared minus 9. And I'm even going to just write off here. You don't have to put this in, but I'm going to put it in just to show you what we've done. We factor out the GCF. And then from here, I can factor it to 3 times x plus 3, x minus 3. That was my dots. It's three terms. It's a trinomial, meaning it's either a perfect squared trinomial, that's like a plus b squared, or it's a regular trinomial, where we need to use our trinomial factoring method. So if you remember our method, the AC method for 6x squared plus 13x plus 5, this doesn't look like any special pattern to me, so the first thing I'm going to do is multiply 6 and 5 together. So 6 and 5 is 30, like my little chart. Now I want to find numbers that multiply to 30 and add up to 13. 10 and 3 hopefully is an obvious example. So I'm going to rewrite it as 6x squared plus 10x plus 3x plus 5. Now if you remember, we're going to factor out by grouping the first two terms and the last two terms. So what can I factor out of 6x squared plus 10x? Well, I can factor out, let's see, what can I factor out? 2 and an x. That leaves me with 3x plus 5. What can you factor out of 3x plus 5? Well, you can factor out a 1. And that leaves me with 3x plus 5. Which, if I then factor that, that leaves me with 2x plus 1 and 3x plus 5, right? So that was our factoring when we had three terms. Well, you can imagine what's happening next. If we flip to the next page, oh no, we've got four terms. Four terms maybe looks a little bit tricky, and in spots it can be trickier. But it's nothing terrible if you kind of just focus on the basics that you've learned so far. I think you'll see that's really not that much different than the things we've done. So let's take a look at 5m plus qm. Notice that m, as I highlighted in colors here, is common to both terms. And if it's common to both terms, I can factor out of both terms. So what I'm going to do is factor out an m. So I'm left with m times, what am I left with? I'm going to be left with 5 plus q. So pretty simple factoring. And again, notice it doesn't leave me with two m's, okay? It doesn't leave me with two m's, it leaves me with one m. And one way to check, right, you can always check by distributing your answer. Okay, so if you were to distribute that m back into the 5 plus q, would you get 5m plus qm? And you would in this case. All right, so let's take a look at number 2. It looks a little bit funny. Okay, I have that x plus y in parentheses. But notice that x plus y is common to both the 5 and the q. So much like I did in the example above, x plus y next to the 5 and the x plus y next to the q, think of it simply like the m's from the problem above. If it's common to both terms, I should be able to factor it out. So if I factor out an x plus y, from each term, what am I left with? I'm left with 5 plus q. So don't think of, don't get confused by what's inside that parentheses and make you do crazy factoring stuff. Treat it just like that m in example 1. Okay, whatever's on the inside of that parentheses, we'll worry about that later, but for now, just treat it as a singular term in terms of how you factor it out. All right, so let's take a look at number 3. This is kind of like the full-on factor by grouping. So I have 5x plus 5y plus qx plus xy. And I want to factor out something that's common to the first two terms and the last two terms. So let's take a look at those two terms and these two terms. For that first two terms in blue, what can you factor out of 5x and 5y? Well, you can factor out a 5. And what are you left with? X plus y. And what can I factor out of the qx plus qy? Well, I can factor out a q, and I'm left with x plus y. And much like the example above, right, when fx plus y is attached to two different terms, I can factor out an x plus y from each term. So I'm just going to factor out the x plus y, and what would you be left with? The 5 plus q. Okay, so as we saw in problem number 3, when we have 4 terms, we will want to try and group them, okay, into two groups, just like we did in blue above, and then factor. What we're really hoping for, and this is critical, what we're hoping for is what's left in each term will be exactly, okay, it's going to be exactly the same. Okay, and as I say here, this is often, not always, but often how we'll solve them. All right, so let's try number 4 together, and I'm going to give you some time to pause the video and try a few on your own before you can come back and check with me. So let's start with x squared minus ax plus bx minus ab. And let's factor by grouping. So let's put in those parentheses around the first two terms and the next two terms. And start by thinking about, all right, well, what's common to the first two terms, x squared and ax? Well, what's common is x. And what I'm left with is x minus a. And then, what's common to bx and ab? Well, it's b, or minus b. And what am I left with? I'm left with x, oops, sorry, take it back, not minus b, plus b. Plus b. And what I'm left with is x minus a. Okay, I can see now that x minus a is common to both the x and the b in blue, which means I can factor out that x minus a. And what I'm left with is the x plus b. Okay? So what I want you to do is try factoring number 5 here. Hit pause for a second. Try factoring number 5 and then see if, once you hit play, if you get the same answer I do. All right, so hopefully you gave this one a shot. Let me run through my answer real quickly. I can factor a b out of the first two terms. So that gives me b times r plus 1. And I can factor a c out of the other two terms. That leaves me with another r plus 1. That's what we want to see. Which now, if I factor out the r plus 1, I get r plus 1 times b plus c. Okay, I think that one was a little bit easier. Maybe even than number 4, but good first one to try on your own. Number 6, a little bit trickier. Pause this video, try number 6 on your own. Notice that those first two terms you're grouping are going to be difference of cubes. That's going to be a little scary. Okay, so try the difference of cubes. Sorry, not difference, sum of cubes. And notice what we have on the second part here. Okay, we've got some funny stuff going on there. I won't say what it is. But pause the video, give this one a shot. When you're done, hit play and see if your answers match mine. Okay, hopefully you did that. Hopefully you also remember that your factors for your sum of cubes is going to be a plus b a plus b times a squared plus ab plus b squared. And this is going to be plus. Notice the second piece is a difference of squares or dots. So what can I factor out? Well, it's going to be a plus b, a minus b. So I have a plus b times a minus b. Okay. Is there anything common to both the two sets of terms that I have? Well, yes, there is. I have an a plus b here, and I have an a plus b here. That means I can factor an a plus b out of both of them. So that's going to give me a plus b. And then what do I have left? Well, I have the a squared plus ab plus b squared, okay, plus the a minus b. Okay, so all of that together is going to get me what I originally started with. Okay, so just be careful. Careful there, there's a lot of a's and b's being thrown around. All right, number 7 looks a little bit different. So if you remember, if we go back a second ago, and I said this is often how we solve them. Number 7 here, okay, is going to be an example where we don't factor by grouping in that sense. So what I want you to think about is, does it make sense to factor or factor by grouping the two pairs of terms, or does it maybe make sense to factor a group of 3? And I'm going to let you think about that. I'll pause the video, see if you can think about which group of 3 terms might be easier to factor, or which ones might be able to factor. That'll allow you to then factor further, okay? So this will not be a case where we do 2 by 2. I don't want you to do that. I don't want you to do this. Don't do that. See if there's a group of 3 that you can factor that will ultimately get us to where we want to go. All right, so hopefully you hit pause and you gave it a shot on your own. Hopefully also that you saw that it made sense to factor x squared plus 6x plus 9. Hopefully that sticks out as something that you've seen before, a pattern you've seen, and you probably know that that factors to x plus 3 times x plus 3, or x plus 3 squared, and we're left with that minus a squared at the end. Well, what I have here is something squared minus something squared. That looks identical to the dots pattern, right? A squared plus minus b squared. Well, if I use the dots pattern, a plus b, a minus b, that's going to leave me with x plus 3 plus a, x plus 3 minus a. Right, in this case, the a is the b value, right? We've kind of swapped, right? The b here corresponds to the a there. So notice that pattern is a little bit different. Most of the time we're going to do 2 and 2. Sometimes it's possible to do 3 and 1. Okay? So what I would like you to do for practice here, okay, for homework before we get on to one more thing, but part of your homework problems are going to be, and I'm going to circle them in green. I want you to try number 8. Okay, give number 8 a try. Try number 9. Okay, we'll try number 9. And we'll try number 10. Okay. That'll be it for 4 terms. So if you want to hit pause and do 8, 9, and 10, feel free to do so. The answers are on Canvas, so I'll let you check Canvas for the answers on those. So hit pause if you'd like, do 8, 9, and 10, or you can continue on with the video and do 8, 9, and 10, and what we're about to do next, do them all after the video at one time. It's up to you. All right, so hopefully you've done 8, 9, and 10. If you're saving them until after the video, that's fine too. What I'd like to do now, and don't get too stressed, is look at expressions where we have 5 or more terms here. Okay, it's going to look a little intimidating, and we're going to have some more practice doing it, but for today, let's try to just get into the basics of it. Let's take a look at 14, okay? And my advice here was your best bet is to try to break it down into 2 groups, 3 and 2 if it's 5 terms, and then look for patterns. Or if it's 6 terms, okay, break it down into 3 and 3, or even 2, 2, and 2. For example, we're going to start with number 14 here. What we're going to do is we're going to use the 3 and 3 method. As you do this more often, the more experience you'll have, you'll gain some more intuition as to when it's 3 and 3 and when it's 2, 2, and 2. But for right now, just bear with me. Let's go with the 3 and 3. So I'm going to start by just breaking this down into that and into that. Okay? 16x squared plus 40x plus 25y squared. That should look, okay, like the sum of two squares, or two terms squared. Okay, notice that the 16x squared, both are squared terms, as are 25 and y squared. So if that's the case, I could factor this to 4x plus 5y squared. And you'll notice that you'll get the middle terms will sum to 40xy. So factoring 16x squared plus 40xy plus 25y squared yields me 4x plus 5y squared. And then I'm left, and I'm actually going to change the parentheses here, and you'll see why in a second, to 4x plus 5y minus 12. And actually what I'm going to do too, just so you can see, I'm going to put a 1 in front of the 4x plus 5y. 4x plus 5y. So what I have here is 4x plus 5y squared plus 1 4x plus 5y minus 12. Now I'm going to do a little substitution. We're not always going to do this, but I'm going to do this right now just so you can kind of see the pattern. I'm going to let 4x plus 5y equal, let's call it u. Okay, we're going to call it u. So wherever I see a 4x plus 5y, I'm going to replace it with a u. So if I do that to my problem here, I have parentheses u squared plus 1, just changing colors, u minus 12. So I have u squared plus u minus 12. That looks like a trinomial we know how to factor. That indeed should factor to u plus 4, u minus 3, right? What multiplies to negative 12 and adds to positive 1. We saw that last week. Now let's remember though, we didn't factor with u. Oh, we did, but the original problem doesn't have u in it. We substituted in u for 4x plus y. So before we're done, we should substitute out that u and put 4x plus 5y back in. And when we do that, we get 4x plus 5y plus 4 times 4x plus 5y minus 3, and I've just factored. Okay, so substitution might be helpful. Factoring the first 3 terms in the original like we did might yield us a squared. Something you might want to look for are terms that have squareds in them, like that, where it often results in that something plus something squared pattern. So that could be really helpful. Okay. So there's a really good example of something with 4 or more terms, or I guess in this case 5 terms. Okay. So I'm just looking through what might be some good ones to do. All right, so for your homework here, and have some patience with yourself on these 5 or more term ones. We'll do some more review with them next class, but I just want to give you an intro there. So in addition to the 8, 9, and 10 that I asked you to do on the previous pages, let's also do, from the little mix here, let's do 16. So the little mix is going to involve a little bit of everything. Okay, let's do 16. Let's do 18. Okay. Let's do 21. Okay. Oops. For 21, I'm just going to put a little note here. Have patience And don't quit after 2 minutes. And say to me next week, I didn't get it. I did not eat. Help me. Okay, you have a teacher there to help you. You've got to try it. You've got to work through different possible scenarios. I only gave you 6 problems to do. It's okay to do it and get it wrong first and have to go back and start over. Okay, 21 will be a tough one. Okay, it will be a tough one. I'll give you a little bit of advice or a hint. I see 2 squared terms here. Okay. Actually, never mind. I take that back. I would start by factoring these 3. Start by factoring out a GCF out of these 3 and see if you can keep going. Okay, this is going to be a trinomial pattern, meaning it's not going to be one of our special ones. It's going to be one where you have to think about what multiplies to this and adds to this. Give that one a shot. It'll be a little bit tricky. Use your teacher for help. And try those 6 ones I circled in green. And I think you guys will be okay. Okay, it's your first day doing this. Have some patience. Next class, we're going to continue to work on it, okay? Good luck.